In our last module, we were talking about functions, and in this module, we're going to look at a specific kind of function called a linear function. The name linear function was chosen because the graph of a linear function is always a straight line. But there is another way of describing a linear function, and that is to describe its equation. So a linear function is a function with an equation that looks like this. f of x equals mx plus b. And you can write the terms in either order. You could write that as b plus m times x, where m and b are specific numbers. In other words, if you choose two numbers m and b, like m equals 3 and b equals 7, then the function f of x equals mx plus b, in our example that would be f of x equals 3x plus 7, is the equation of a linear function. So here are a few other examples. G of x is 1/2 x plus 2/3. Here the number m that I chose was 1/2. The number b that I chose was 2/3. I'm choosing these numbers more or less randomly to get examples. H of x is minus 2x plus 4. Here the number m is minus 2, and the number b is 4. And finally, L of x, 9x minus 5. Here the number m, the multiplier for x, is 9, and the b is minus 5. One thing to notice about this third example, I could have written it like this: L of x is 9x plus a minus 5. This would be in the correct form, mx plus b. But usually when b is negative, like b equals minus 5 in this case, we write the formula in simplified form. 9x minus 5 rather than 9x plus a minus 5. Just a reminder that for any function f and any number a, not necessarily a linear function, but any function f, f followed by a in parentheses, that's read f of a, you remember, means the number you get when you plug a into the formula for f. It doesn't mean you're multiplying f by a. It means plug the number a into f's formula. So there's one reminder from our previous module. And the second reminder is that f of a is the height of the graph of f above a. So let's go back to looking at an example of a linear function, f of x equals 3x plus 7. It's not too hard to see that if you plug in 0, f of 0, you get 7. F of 0 means that you replace x by 0 in the formula. So that means that the height of the graph of the function f above 0 is 7. So here is a coordinate system. So here is a 0 on the x-axis. Go up 7 units. You will be on the graph above 0. So 7 is the height of the graph where the graph crosses the y-axis. And this number is usually called the y-intercept of the graph. The height of the graph when it crosses the y-axis is the y-intercept. Okay, still looking at the function f of x equals 3x plus 7. I want to look at what happens if you increase x by 1 unit. So what I'm saying here is that if you increase x by 1 unit, then f of x, that's the 3x plus 7 here, will increase by 3 units. For example, if x goes from 1 to 2, that's an increase of 1 unit. Then f of x will go from f of 1, which is 3 times 1 plus 7, or 10. It will go from f of 1 to f of 2, which is 3 times 2 plus 7, or 13. So we see that the effect of increasing x by 1 from 1 to 2 has the effect of adding another 3. So this illustrates what I was saying in this first line here, that if you increase x by 1 unit, f of x will increase by 3 units. The increase in f of x per unit increase of x is called the slope of the graph. In general, if you have a linear function, f of x equals mx plus b, then the y-intercept, the point where the graph crosses the y-axis, will be the number b, and the slope, which is the increase in f of x per unit increase in x, will be the number m. We'll try this example. So here is a linear function, and the question is, find the y-intercept and the slope of this linear function. We'll fill in the boxes. So here I have written the equation once more. Okay, the y-intercept is the numerical term, the 3/4. And the slope is the multiplier for x. The slope is -4. And one thing to note here is that the slope is -4, not -4x. Both the y-intercept and slope are numbers. Evaluating a linear function is a fairly easy thing to do. We'll try an example here. Let's try our example. F of x is 3x plus 7. What is f of 2? This means replace x by 2 in the formula. So we're replacing x by 2. We would have 3 times 2 plus 7, 6 plus 7, or 13. And now we're going to talk about some things that you can do if you know f of a and f of c for two different numbers, a and c, assuming that f is a linear function. One thing you can do is draw the graph. So let's see how that works looking at an example. So suppose we know that f of 1 is 2 and f of 3 is 1, and that f is a linear function. And I want to draw the graph of f. Okay, so here is my coordinate system. Knowing that f of 1 equals 2 means that the point 1, f of 1, which is the point 1, 2, is on the graph. Right? The height of the graph above the number 1 on the x-axis is 2. And the point 3, f of 3, is on the graph. In other words, the point 3, 1 is on the graph. So knowing that f of 3 equals 1 tells me that the height of the graph above 3 is 1. That would be the point 3, 1 on the graph. So there are the 2 points on the graph. 1, 2, the point 1 unit to the right and 2 units up from the origin, and 3, 1, the point that's 3 units to the right and 1 unit up from the origin. And now we know the graph is a straight line, so all that's left to do is connect the 2 points with a straight line, and we have the graph. So knowing what f of 1 and f of 3 are is enough information to draw the graph of a function. You can use the same procedure to draw the graph of a linear function if you know the equation. There's just one extra step at the beginning. You've got to find f of a and f of c for 2 numbers a and c. If you know the equation, this will be a fairly easy thing to do. So let's try drawing the graph of f of x equals minus 2x plus 1/2. Okay, so step 1, we're going to find 2 points on the graph by choosing 2 numbers, a and c, and calculating f of a and f of c. You can choose any 2 numbers you like for a and c. When I'm doing this, I frequently choose a equal to 0 and c equal to 1, because calculations with 0 and 1 are usually pretty easy. Okay, choosing a equal to 0 and c equal to 1, and having this formula for f of x, we know how to calculate f of a, or f of 0, and how to calculate f of c, which would be f of 1. F of 0 is minus 2 times 0 plus 1/2, plugging 0 into the formula for f. Minus 2 times 0 is 0, plus 1/2 gives me 1/2, and f of 1. Sorry, so the point 0, 1/2 is on the graph. And now we move to calculating f of 1. We're plugging 1 into the formula for f. Minus 2 times 1 plus 1/2. Minus 2 is minus 4 halves. I wrote this as some number of halves so I could add the 2 fractions. And minus 4 halves plus 1/2 is minus 3 halves. So the point 1 minus 3 halves is on the graph. Then step 2, we draw the graph using the 2 points, just like we did in the previous example. So here's my coordinate system. I locate the points 0, 1/2. That will be 1/2 unit up from 0. And the point 1 minus 3 halves, that will be 3.5 units, 3 halves units down from 1. Right about there. You plot those 2 points, and then you connect with a straight line, and you have the graph. Okay, here's something else you can do if you know f of a and f of c for 2 different numbers a and c. You can find the slope. You can find the number m. So let's try this out on an example. So let's suppose we know f of 1 is 2 and f of 4 is 8, and that f is a linear function. We want to find, our goal here is to find the slope, m, of the linear function. So we know that as x goes from 1 to 4, f of x goes from 2 to 8. So going from 1 to 4 is a change in x of size 3. The distance from 1 to 4 is 4 minus 1, which is 3. The change in f of x from 2 to 8 will be f of 4 minus f of 3. It'll be 8 minus 2, which is 6. So a change in x of 3 units produces a change in x of 6 units. What will a change in x of 1 unit produce in f of x? Well, 1/3 of 6. Since the change in x, since a change in x of plus 3 produces a change in f of x of 6, a change of 1 in x will produce a change in f of x of 1/3 times 6, or 6/3, which is 2. So this is the change in f of x per unit change in x, and that's how we defined the slope earlier. So the slope is 6/3, or 2. And in general, if you know f of a and f of c for two different numbers, a and c, then you can calculate the slope of the graph this way. This is what we did in the example. We took f of c minus f of a, that's the change in f, and we divided by c minus a, that's the change in x, and that gave us the unit change in f of x. That gave us the change in f of x per unit change in x. I put the outer parentheses around the numerator and denominator because they will be necessary on some calculators if you're doing this calculation using a calculator. Let's try another example. So this time we have a linear function, and we know f of minus 1 is 3, and f of 4 is minus 2, and we want to find the slope. We want to find m. This time I'm simply going to use the formula. So a is minus 1 and c is 4. And the formula for the slope is f of c minus f of a. This is the change in f of x as x goes from a to c, divided by c minus a. This is the change in x from a to c. I've left off the outer parentheses around the numerator and denominator because I'm going to do this calculation by hand. Okay, f of c is f of 4, which is minus 2, and f of a, since a is minus 1, is 3. So f of c minus f of a will be minus 2 minus 3. C is 4, a is minus 1, so in the denominator we are subtracting minus 1 from 4. 4 minus a minus 1. Looks like minus 5 over 5, or minus 1 is the slope in this example. You can also find the y-intercept if you know f of a and f of c for two different numbers a and c. Here is an example we're going to try. We're going to say we know that f of 1 is minus 1 and f of 3 is 5. And we know that f is a linear function. Our goal is to find the y-intercept of the graph of f. So f of 1 equals minus 1 tells us that the height of the graph above 1 is minus 1. In other words, the graph is 1 unit down from the x-axis. F of 3 equals 5 tells us that the height of the graph above 3 on the x-axis is 5. In other words, the points 1, minus 1 and 3, 5 are on the graph. So we start our calculations. The equation of f of x, since f is linear, looks like this. It's m times x plus b. M is some number, the slope, and b is some number, the y-intercept. The first step is to find the number m, the slope, which was what we did in our previous calculation. The slope is f of c minus f of a over c minus a. In this case, c is 3 and a is 1. F of c is 5 and f of a is minus 1. So I will be plugging in those numbers. 5 minus a minus 1 over 3 minus 1. Looks like 6 over 2, which is 3. So as we did in the previous example, we found the slope knowing the value of f of 1 and f of 3. Now we know what m is. So we know that the equation looks like this. F of x is 3x plus b. I'm filling in the value of m that I found in the previous step. I'm going to choose one of the 2 points, either 1, minus 1, or 3, 5. Doesn't matter which one I choose, so I'm going to choose 3, 5. So we know that f of 3 is equal to 5. So I'm going to plug those numbers into this equation. When x is 3, f of x is 5. So in this equation, f of x is 3x plus b. We're replacing x by 3 and f of x by 5. Looks like this. 5 is 3 times 3 plus b. Or if you multiply 3 times 3, you get 5 equals 9 plus b. And now the last thing we have to do is solve this equation for b by subtracting 9 from both sides. B is minus 4. So this is how you can find the y-intercept, the number b, knowing f of a and f of c for 2 different inputs, a and c. And the final thing that we're going to talk about that you can do if you know f of a and f of c is find the equation of the linear function. Actually, we've essentially done that. Once you know how to find the slope m and the y-intercept b, you know what the equation is. So let's try this out on an example. Let's say f of minus 2 is minus 3, and f of 3 is 10. So I know f of a, and I know f of c for 2 different numbers, a and c. A is minus 2 and c is 3. We're going to repeat the same procedure that we've been going through. You first find the slope. The slope is f of c minus f of a over c minus a. F of c is this 10. F of a is this negative 3. C is this 3. And a is this minus 2. 10 minus a minus 3 over 3 minus a minus 2. 10 minus a minus 3 is 10 plus 3, or 13. And 3 minus a minus 2 is 3 plus 2, or 5. 13/5 it looks like our slope is. And then we find the y-intercept. So moving on to a new slide where I have a little more room, we found the slope is 13/5. Now we're going to find the y-intercept. So there are 2 points on the graph. There's the point -2, -3, and there's the point 3, 10. And I can choose either one of those, but I've decided to use the point -2, -3. Since the slope is 13/5, we know that the equation of the linear function f looks like this. It's f of x equals 13/5 times x plus b. And now I'm going to plug in this point. When x is -2, f of x is -3. That's really this first equation here at the top. So we are replacing x by -2 and f of x by -3. So -3 is 13/5 times -2 plus b. And if you multiply 13/5 by -2, you get -26/5, and now we are solving for b. We're adding 26/5 to both sides. So b is -3 plus 26/5. Well, in order to add these two numbers, if I'm doing it with pencil and paper, I have to write -3 as some number of fifths. -3 is -15/5. So -15/5 plus 26/5 is 11/5. This is b. We now have everything we need to write down the equation. We have the slope, which is 13/5. We have the y-intercept, which is 11/5. The formula, the equation for f of x is f of x equals 13/5 times x plus 11/5.